So, welcome to lesson 54 of my advanced mathematics or algebra 3 class, whatever you want to call it. We are going to refresh our memory on how to complete the square in order to graph a parabola. So, remember, it is a second degree trinomial that we have set equal to y. This is our function. And it is a function. As long as it's pointing up or down, it is a function. So this is our problem. Y is equal to x squared minus 4x plus 2. Remember that this plus 2 is our y-intercept. So we can actually go on the graph and go ahead and put in 0, 2 as the y-intercept. That is where our parabola is going to cross the y-axis. Then we're going to complete the square. So what we have to do to complete the square, I'm going to erase this just for the time being. We we create a new trinomial place, and we just kind of move the positive 2 to the outside. We leave space for a third term here and move this to the outside. And then what we do is we take the middle term, the middle coefficient with whatever sign's in front of it, and we divide it in half by or divide it by 2 by multiplying it times 1/2. So this is negative 4 divided by 2. That gives us a negative 2. And then that gets squared. And the answer is positive 4. So that is what we write. I think I'll keep this green. In here, we add 4 to our perfect square. But to keep this equation balanced, we can't just add numbers willy-nilly. If we add, we have to subtract to the same side. It's the same thing as if we had said adding 4 over here, but then we subtracted 4 from this side, so we had to subtract 4 from this side to keep it balanced. It's the same step, we're just skipping this part of it, and we're moving ahead to adding 4 and subtracting 4 from the same side. And what that does is it cancels each other out, and it means this side really hasn't changed any. The value of the side, the plus 4 minus 4, that's 0. Right? So it doesn't change that. The equation part of it, it remains true. Then we factor it to make it our square. And when we do that, we are able to find the axis of symmetry and the x value of our vertex. So when we do that, we take this value here and we multiply it times the negative 1. It's the opposite of whatever this number is. So our vertex x value is 2. But then our axis of symmetry, which is this pink line running right here, is also positive 2. I can spell symmetry. There we go. So this is our axis of symmetry, and it's also the x value of our vertex. The y value of our vertex is going to be the combination of these two values on the outside. And it doesn't change. It's exactly the way it is. We just take it at its current value. So then the vertex would be 2, positive 2, negative 2. So we put in our vertex. We've already had in our y-intercept. And then because now we know, if you draw in your axis of symmetry, now we know how far away, because this is symmetry, we know how far away this point is from the axis of symmetry. We count those spaces, 1, 2, and then we count the same number of spaces, 1, 2, to get the other point that allows us to draw the parabola. And then once we get those 3 points, then we can just, it shows us which way it's opening, so we can just draw our little curve through those 3 points. Easy peasy. Okay? So remember, this is our y-intercept. We set it up so that we can add a third term, and we move this y-intercept to the outside. Then we take the middle coefficient, we divide it by 2 or multiply it times 1/2. Whatever that number is, we square it. And that is the number that we add and subtract We add it inside. Now, if it's a negative number, it won't be a negative number because when you square, even if it is a negative number, when you square it, it'll be positive. So that's the number we add to the middle and subtract from the outside to keep it balanced. You don't even have to factor this. It's whatever number this calculation came out to be before it was squared. That's what goes here. So you say x and this term here, and then you put your square on it. And then that becomes the opposite of that number, becomes your axis of symmetry and your x value. And when you combine whatever's on the outside, that becomes the y value of your vertex. Then you just use the axis of symmetry and your y-intercept to get the mirror imaged point or the balancing point, and then you graph. Those are your steps. All right, so we have one more. So here we have 54.2, and we have a negative x squared minus 6x minus 8 is equal to y. So first of all, we find our y-intercept, which is going to be 0, negative 8. So I go ahead and I graph 0, negative 8. And then I factor, because we don't want to have anything in front of our x squared except 1, positive 1. If you have a 2 or a negative or a whole number or anything other than just a plain old x squared, we've got to factor that out, but we do not include the y-intercept. So we move it to the outside. So what happens is it looks like this. We move it to the outside and we factor this negative out of the negative x squared and the negative 6x, and we have positive x squared plus 6x, and then we have room for that third term. We've put our negative on the outside. Okay, so what happens with that is the same process as before. We take the 6, we multiply that times, it's a positive now, so we multiply that times 1 over 2. That would be 3 squared, right? So that is going to equal 9. So 9, we would add 9 here. And normally we would subtract 9. But when you move something outside of the parenthesis, you have to apply whatever factor is in front that you factored out to that value so that it actually does cancel out in the long run. Because otherwise, once you multiply this times this positive 9, then you've subtracted 9 twice. So you have to apply this factor here so that you get that true opposite value, or the true unfactored value. So the negative 1 times a negative 9 would make that a positive 9. And that's why we're adding 9 twice. It actually does balance out, because when you apply this negative 1 to this positive 9, it becomes a negative 9. And negative 9, positive 9 is 0. So it balances. So you have to take that into consideration when you factor something out, and then you put this term on the inside and you go to subtract it from the outside. Multiply it by whatever this factor is here before you subtract it. Okay. So now we just factor this, being negative x plus 3, and all of that will be squared. So negative 3 is your axis of symmetry and your x value of your vertex. And then positive 1 becomes the y value. So your vertex is negative 3, positive 1, which is right here. And once I put this in and I was able to find my axis of symmetry, I was able to put in the corresponding mirrored point, which would be negative 6 and 8. So then all I had to do was put in my vertex and then draw in my parabola. And this one opens down because it is a negative value. Now, we do not take the negative of this. We do not take this and multiply it times the factor. We take it just like we normally do. We take the opposite of what is inside the squared factor. This does not apply. This remains -3, 1. All right. So that is all we have for lesson 54. We were just reviewing how to do the parabolas and reminding ourselves we did these towards the latter end of Algebra 2. We're just refreshing our memory. That's all lesson 4 was about. So, ta-da, we had an easy day. I will see you in lesson 55.